At 7:30 a.m. local time on June 25th, a strong magnitude 6.9 earthquake struck offshore of northern Honshu in Japan. This made the ground subsequently move back and forth for at least 15 seconds across a wide area, making items fall off of shelves, creating limited minor damage, and causing a few but overall low number of injuries. Despite the fairly high magnitude of the earthquake which struck, its offshore location and intermediate rather than shallow depth meant that its effects were not severe. That magnitude 6.9 earthquake just so happened to denote one of the 10 largest earthquakes to occur so far in 2026, and, strangely enough, it occurred during a single 26-minute time span where two other of 2026's 10 largest earthquakes so far struck. These earthquakes also occurred on the same day as a power outage causing earthquake in California, a magnitude 5.6, which marked the largest on-land earthquake the state had seen in 4.5 years. While many people have wondered if these three distinct earthquake sequences were related to one another in California, Venezuela, and Japan, they absolutely did not trigger one another and had no relation to each other. The human brain wants to find a pattern or order in a chaotic system of which there is no pattern when regarding what world earthquakes strike on a particular day. In other words, their close spacing merely was an oddity of random chance. I have been playing a bit of catch-up to discuss each of these distinct events in detail, and since I already discussed the Venezuela and California earthquake sequences, here's why the magnitude 6.9 earthquake struck offshore Japan early on June 25, 2026. Offshore of this section of Honshu, a tectonic plate collision is ongoing. There, the west-northwestward moving Pacific plate is colliding with and subducting underneath the Okhotsk plate. While the boundary between these two tectonic plates can generate megathrust or large magnitude thrust fault earthquakes that can generate damaging tsunamis, that is not what produced the magnitude 6.9 earthquake. I say this because those types of earthquakes generally occur at less than 25 kilometers depth, but always at less than or equal to 35 kilometers depth. Yet, the 6.9 earthquake which struck had a hypocenter at 50.9 kilometers or 31.6 miles depth. In other words, it struck purely within the subducting Pacific plate being known as an intraslab earthquake. This intraslab earthquake occurred for two reasons. As the subducting Pacific plate descends deeper into the mantle, it both becomes denser and is pulled downward at a progressively steeper angle. This causes the subducting slab to bend, and this causes compressional stress to build up. Eventually, some of this stress that built up was released via a westward dipping reverse fault with an approximately 35 km long segment of such slipping to generate the observed earthquake. Due to its depth, the strongest ground motion this magnitude 6.9 earthquake produced at a spot on the surface was only an MMI of 6.5. Hence, damage in that narrow area might fall about halfway between these two descriptions. Intraslab earthquakes are fairly common seismic events and can be identified largely by their hypocenter depth. Because this was not a megathrust type earthquake, in my opinion, it should have absolutely no impact on the chance of a potential magnitude 8.0 or greater megathrust earthquake striking in a part of the subduction zone by 2055. For reference, there are 3 subduction zone segments in Japan deemed at increased risk by 2055 of producing a magnitude 8.0 or greater megathrust earthquake compared to other segments where there is a convergent plate boundary in Japan. In this instance, there is an estimated chance of about 30% of one of these two areas producing such a magnitude 8.0 or greater quake by 2055. I hope that you found this video interesting. As a final note, I would like to thank my new patron Theodore Miller for supporting my work.